far we have learned that if we have an electric charge like an electron standing still, we will have an electric field E surrounding the electric charge. If the electric charge starts moving with constant velocity, the field lines, as you can see in the picture of the electric field, will change shape, and also we will have a magnetic field being produced. But in none of these cases we will have electromagnetic waves. Here we saw that electromagnetic waves can be produced when the electric charge is oscillating up and down, like what is happening in a radio antenna. And you can see the patterns that the electric field lines can have when a charge is oscillating up and down, as you can see in the series of pictures below. So we discussed this with details, and the most important point here is to remember that when we have a charge oscillating up and down, we will have electromagnetic waves. When your mobile phone sends a text message or photo, the information is transmitted in the form of electromagnetic waves produced by electrons accelerating within the phone's circuits. Picture B. Power lines carry a strong alternating current AC, which means that a substantial amount of charge is accelerating back and forth and generating electromagnetic waves. These waves can produce a buzzing sound from your car radio when you drive near the lines. In this picture you can see a broad range of electromagnetic wavelengths found in nature, as you can see from radio to gamma rays. So the top rulers show the wavelengths in meter, and the bottom ruler is just showing the frequency in hertz. So the radio from 10 to 1 meter, microwaves from 1 to approximately 10 to the power minus 4 meter, infrared, and you can see in the middle of the band there is a narrow white bar which belongs to visible light, and it starts from 700 nanometer to 400 nanometer. So it's the only range of electromagnetic waves that is visible to our eyes. And as we go forward, we have ultraviolet, X-ray, and gamma rays. Many insects and birds can see ultraviolet wavelengths that humans cannot. As an example, the left-hand photo shows how black-eyed Susans, this kind of flower, look to us. The right-hand photo in false color, taken with an ultraviolet sensitive camera, shows how these same flowers appear to the bees that pollinate them. Note the prominent central spot that is invisible to humans. Similarly, many birds with ultraviolet visions, including budgies, parrots, and peacocks, have ultraviolet patterns on their bodies that make them even more vivid to each other than they appear to us. So as you can see in this picture, this kind of bird, which is called starling, how it can be seen differently by human eyes and a bird eye. So you can see in the right picture, the bird vision includes also the ultraviolet wavelengths, as you can see in the bottom graph, 370, which is shown by pink, actually is an ultraviolet wavelength, and but the human eye kind of stopped at 400 nanometer, and we're not able to see that pink color, which is actually a representation of ultraviolet here. And you can see how the two vision can be different in reality.